So if you remember, I said that we would be doing all kinds of transformations. The first one was a translation where we just moved it. The second one is a reflection, so that's where we're going to flip it, a mirror image, across a line. So this box up here is just trying to show you that you will always have a line of reflection that you will reflect a figure across, and that notice that from this point to my line of reflection is the same distance from that line of reflection to that reflection point. So the point is, how many times can I say point? The point is that we want to make sure that we have that equidistance all the way across there. So how would we reflect on a figure? So problem 1. It says point P has coordinates 3, 4, and what are the coordinates of capital R, y equals 1 of P? So that notation is saying that it wants you to reflect across y equals 1, and you're going to reflect P. So the first thing I did was I came over and plotted that point 3, 4. So I went right 3 and up 4. Then I went in and drew in my line. So remember, if I have a y equals kind of equation, that's going to represent a horizontal line because it's going to cross through my y-axis. If I have an x equals some number, that's going to represent a vertical line. So I have y equals 1, which is a horizontal line across there. So I would encourage you to draw that in there so that you can always see it. You're going to count perpendicular to that line how much I am away from there. So if I were to count down, since I'm going to be perpendicular, I went down 3. So you're going to do that same thing from that line. So I just count 1, 2, 3, and that's how I know how to put my reflection point. So the coordinates of that reflection point would be 3, negative 2. Okay, pause the video and see if you can try the next one. So on the next one, it's wanting you to reflect that same coordinate. So I went ahead and graphed it. And then it wants you to reflect across x equals 1. So remember, x equals 1 means I'm at 1 on the x-axis and I'm drawing through that vertical line. Now I'm going to count across how many points I have. So if I want to go perpendicular to it, I count this way. So I'm counting 1, 2. So that means I have to count 1, 2 to put my point in there. So my reflection point would be at negative 1, positive 4. Okay, now we're going to reflect a whole image. So now it says graph these points and then graph and label the reflection of that triangle. So here is my original. The pink is my original triangle. So A, B, and C are these 3 points. So I would go ahead and plot those. So I would pause the video for you. And then you're going to want to reflect across the y-axis. So I went through and dashed the y-axis, but it's kind of hard to see. So I would do that, and then you're going to count across that reflection line to see how far we need to go. So like for A, I counted right 3, so then I counted right 3 again, and then put in my reflection point, which would be A prime. Then I did B. B is on my line of reflection, so it's not moving, so that means the reflection point would also be in that same spot. So B prime is also in that same spot. Then I reflected C, so I counted left 4 to my reflection line, and then I would count 4 more left and put in my reflection point. Then I just connected all 3 of those, and that would be my new image. Okay, see if you can do the next one. So on the next one, it wants me to continue to use that problem from the previous, so I went ahead and graphed the triangle ABC. Now it wants me to reflect across the x-axis. So I drew in my reflection line, which if you can see is that blue line across the x-axis, and then I started counting my reflection points. So for A, I counted down 4 to the reflection line, so I would keep counting down 4, and there's my reflection point. From B, I counted down 1 to my reflection line, so I would count down 1 more. And then for C, I counted down 2, so that means I would count down 2 more. Okay, that's it for reflections. Just making sure that you're going to that reflection line in a perpendicular line, and then the rest is just for itself.